In this lesson, we are going to be finding the roots or solutions of a polynomial function. But in this lesson, we do not know any of the roots to begin with. So we first need to talk about the rational root theorem. This is where we can use part of the function to find possible roots to test to find out if they are solutions. The way that we do this is we take the constant term at the end and we find all of the factors of that term. So all the factors of negative 24, we know that 1 goes into 24, and we also know that negative 1 can go into negative 24. So we list both the positive and the negative for all of these factors. We know that 2 goes into 24. We know that 3 goes into 24. We know that 4 goes into 24. We know that 6 goes into 24. 8, 12, and 24. Then we find all the factors of our leading coefficient, which is 3. And we know that 1 and 3, doing both the positive and the negative, can go into 3. Our final step is we take all of these factors of the constant term and we divide them each by the factors of the leading coefficient to find our possible roots. So 1 divided by 1 would be 1. 2 divided by 1 would be 2. 3 divided by 1, 4 divided by 1, 6 divided by 1, 8 divided by 1, 12 divided by 1, and 24 divided by 1. Then we take them each divided by 3 to find our other factors. So 1 divided by 3 would be plus or minus 1/3. 2 divided by 3 would be plus or minus 2/3. 3 divided by 3 is 1, and since I already have that listed, I don't need to put it again. 4 divided by 3 is 4/3. 6 divided by 3 is 2, and that was already listed. 8 divided by 3, 8/3. 12 divided by 3 is 4, and that was already listed. And 24 divided by 3 is 8, and that was already listed. So these would be all the possible solutions that we could have for this particular polynomial function. Well, that's a lot. That would be a lot to test with our synthetic division. And we already know that the fundamental theorem of algebra says that the degree of our polynomial is how many roots we have. So how do we narrow this down? Well, first of all, let's practice this. So if we have x squared minus 2x minus 1, how many roots, which means solutions, does our polynomial have? Remember, it's the largest degree. Next one would be 5 roots or 5 solutions, because that would be to the 5th degree. All right, next problem. Find all the zeros, and then we're going to use synthetic division, factoring, or quadratic formula if we need to find all the solutions of our polynomial function. So first it asks us to list all the possible rational roots. So remember, the first thing we do is we take a look at our constant term and we find all of the possible factors of 15. So we know that 1, we know that 3, we know that 5, and we know that 15 are factors of 15. Then we want the factors of our leading coefficient. Well, our leading coefficient is 1. So we would divide all of these by 1. We would get these as our possible solutions and no more, because we've been dividing by 1. Now it says to use synthetic division, factoring, and/or quadratic formula to solve. Well, the problem is that we have many to choose from. And if we had to do a synthetic division problem for each of these, it would take a while. So if you would pull up your graphing calculator, our Calculator Pro, and if you would go to press Y equals, and then if you would go to punch this equation into that calculator. So I want to do x to the third power. X to the third power, we use our upside down V for our exponent key. Let's see, where is that? Oh, here it is, x to the third power. And then plus x squared. The x is right up here by the green alpha key. Oops, I went to the wrong spot. Let's clear that out. Go back up. All right, so x squared. And then we want a minus x. And then we do plus 15. And then we press graph. So we can make this smaller or larger depending on, but right away I can see that one of my solutions, is -3. That's where my polynomial is crossing, which is at -3. So if we go back and we use synthetic division and we put our -3 in, make our box, and our coefficients of our polynomial function will be 1, 1, -1, and 15. So remember, we're going to bring down the 1, multiply, add, multiply, add, multiply, add. So we have a 0 remainder, which means that -3 is a solution. Now we're going to take what we have left after we've divided and create the next function, x squared minus 2x plus 5 equal to 0. So it says we can use synthetic division, factoring, or quadratic formula. So if we were to try our x for factoring, we would put 5 in the top and -2 in the bottom. What two numbers multiply to be 5 but add up to be -2? So we know that that doesn't work. We also, the factoring doesn't work. We know that synthetic division probably won't work again either, so we need to use the quadratic formula. So we have x equals -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. X equals 2 plus or minus. So -2 squared is 4. And then we have -4 times 1 times 5 would be -20. And when we add those together, we get -16 all over 2. So when we make our factor tree, or knowing that 16 is a perfect square, we have 2 plus or minus 4i all over 2. So final answer, we can divide all of those by 2. So we have 1 plus or minus 2i over 1, which we don't have to put, and that'll be our other two solutions. So if we want to find, again, all of our possible roots, remember the first thing we do is we find all of the factors of 5. So we'd have plus or minus 1 and plus or minus 5. And we're going to divide them by the factors of our leading coefficient, which is 2. So we have plus or minus 1 and plus or minus 2. So we have to simplify. So 1 divided by 1 is 1, and 5 divided by 1 is 5. Then we take the 1 and we divide it by 2 to get 1/2, and we take the 5 and we divide it by 2 to get 5 over 2. So now if we go to our graphing calculator, we want to put 2x cubed minus 5x squared minus 2x plus 5 in our calculator. So press y equals, we can press clear. So we press 2x cubed. And then you want to press that right arrow key, which is going to allow you to move back to the, down to the position to enter the next characters. Minus 5x squared minus 2x plus 5. And then press graph. So when we look at this polynomial function, we are looking for the solutions or the roots, and that's where you're crossing the x-axis. So it looks like we could either pick positive 1 or negative 1 as where we're crossing the x-axis. So let's pick positive 1 to go in. So positive 1, and we will do our synthetic division. So we have a 2, a negative 5, a negative 2, and a positive 5. So we'll bring down the 2, multiply, add, multiply, add, multiply, and we know because we have a remainder of 0 that 1 was one of our solutions. So we have 2x squared minus 3x minus 5 equals 0. So let's try factoring that. So in the top we'll have our negative 10, and the bottom we'll have negative 3. What two numbers will multiply to be negative 10 but add up to be negative 3 would be negative 5, positive 2. But because the leading coefficient is not 1, we want to make our box. We'll put our 2x squared and our negative 5, and then we have negative 5x and positive 2. So, oops, forgot my x. So we're looking for the greatest common factor of the first row would be 2x, and then negative 5. And of the column, we'd have x, and we'd have plus 1. So we can set each of those equal to 0. And when we subtract 1, our next solution would be x equals negative 1. And then when we add 5 and divide by 2, so we have x equals 5 over 2 as our other solution. And then our original solution of x is equal to 1 as well. Okay, so moving along, again, using synthetic division, factoring, or quadratic formula to find all the solutions. This one does not ask us to list all of the possible solutions. So what I would suggest is going to your calculator right away and pressing y equals, pressing clear, and then putting this in to our calculator right away to find one of our possible solutions. So we have x to the 4th, use your upside down V for press the right arrow to get down, minus 3x, upside down V cubed, press the right arrow, plus 6x squared minus 2x minus 12. Okay, double check that. Now press graph. All right, so it looks like for sure we have negative 1 and positive 2 as two of our roots. So let's do positive 2 and use synthetic division. So positive 2 on the outside. We have a 1, negative 3, 6, negative 2, negative 12. So bring down the 1, multiply, add, multiply, add, multiply, add, multiply, and we know we're ending with 0, which means that we know that x equals 2 is one of our solutions. So we have x cubed minus x squared plus 4x plus 6 is equal to 0. We also knew, if we look back at our graph, that -1 is a solution. So if you'd like to do that, we could do -1 as one of our solutions. And we could make another synthetic division, and we could use these coefficients. So we have 1, -1, 4, and 6. So we'll bring down the 1 and multiply. We will add and multiply. We will add and multiply. And we can see that x equals -1 is another solution because we don't have a remainder. So we're going to take a look now at this problem with what we have left and rewrite it as a quadratic. So we have x squared minus 2x plus 6 equals 0. So we could try our x. 6 would go in the top and -2 in the bottom. What two numbers multiply to be 6 but add up to be -2? That is not going to work. And synthetic division, we didn't see any other zeros. So we are at the quadratic formula. So we have x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. This looks similar to one that we've already done. So we have 4 minus 20. So we have x equals 2 plus or minus square root of -16 over 2. And we already took care of knowing that this would be 2 plus or minus 4i over 2, which would be 1 plus or minus 2i. So that would be our other two solutions. All right, in the next example, our last example, again, it doesn't say to list all of, it does say to put all of the possible roots on here. So we're going to do that first. Remember, we're looking at the factors of 8, which would be plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Divided by the factors of the leading coefficient is 1. So when you divide all of these by 1, that would be the possible solutions. So now we want to go back to our calculator. And we want to enter x cubed minus 4x squared plus 2x minus 8 into our calculator. So go to y equals, clear the last one out that we had, x to the third power minus 4x squared plus 2x minus 8, and then we press graph. And it looks like one of our solutions is at 1, 2, 3, 4. So we'll go and do our synthetic division, and we will put a 4 on the outside of our box, and our coefficients from our polynomial would be 1, -4, 2, -8. So we bring down the 1, multiply, add, multiply, add, multiply, and add. So our first solution, x equals 4. Then we're going to rewrite that polynomial, x squared plus, we don't have to put 0x, plus 2 equals 0. In this case, we can solve, which we didn't have as one of our methods, taking the square root. So we are going to subtract 2 from both sides. Then we're going to take the square root of both sides. We have plus or minus. I comes from the negative, and the square root of 2 will stay under the radical. So we have our 3 solutions. This is solving our polynomial, finding all the solutions by first finding the possible solutions, then using synthetic division, factoring if we can, quadratic formula if we need to, and then also we could solve by square